Okay, dear students, welcome to my class on the topic normality. My topic in this session is very clearly, it is called as normality of solutions. You are already familiar with some of the important concentration terms in the previous class. I have introduced molarity, molality, mole fraction. Now I am introducing normality. First of all, we will see the definition to go ahead in this concept. That is, what is the definition of normality? The number of gram equivalent weights, number of gram equivalent weights of the solute present in 1 liter of the solution. 1 liter, you know, 1 liter is 1000 ml. 1 liter of the solution, that is called as normality. So what is normality definition? This is the definition of normality. Let us see the definition once again clearly. That is, the number of gram equivalent weights of solute present in 1 liter of the solution. Here normality actually is little different from that of molarity and molality, because we are mentioning gram equivalent weights, a new thing we are introducing. So in this we have to learn some additional information about this, what is exactly gram equivalent weight. Okay, that we will learn. Before that, we will write the mathematical formula of this normality. Normality symbol is capital M. Normality is equals to number of gram equivalent weights. If you say N is the number of gram equivalent weights, divided by volume of the solution. This is gram equivalent weights, volume in liters. Then this N by V is the formula of normality. If you want to clearly write this one, little bit expanded one, then N is nothing but weight of the solute by gram equivalent weight of the solute. Here what N I am taking is gram equivalent weights, okay. So if you write in detail, then it will become weight of solute by gram equivalent weight of solute, that is N. So what is the N? Weight of the solute we are taking WA by gram equivalent weight GEWT into 1 by V in liters. So V is the volume of the solution in liters. Or else if you want to express this one, volume of the solution in ml, then WA by weight of the solute, that is G. What is G? Very clearly I am telling, what is G? Weight of the solute. What is the WA? Weight of the solute. You can use G, you can use N, anything, but we are using WA from the beginning. So we are using WA divided by GEW into 1000 by volume in liters, volume of the solution in ml in ml. So, this is normality detailed mathematical formula. So, go through the formula once again. What is normality formula? N is equals to weight of solute. What is WA? Once again, if you have any confusion, that is WA is nothing but weight of solute. Okay, weight of solute. See the formula. Normality is equals to weight of the solute by gram equivalent weight GEWT into 1000 by volume of the solution in ml. So, here we are going to talk about what is number of gram equivalent weights. What is gram equivalent weights? This gram equivalent weights actually is nothing but that tells about how many parts of this substance is there solution that will displaces the one part of hydrogen or 1.8 parts of oxygen or 35.5 parts of the chlorine by mass. That is gram equivalent weight. Gram equivalent weight meaning is nothing but number of parts of a substance. Number of parts of a substance means solute substance that replaces or displaces, you can write that displace one part of hydrogen or 8 parts of oxygen or OR, this is OR 35.5 parts by mass of chlorine. That is called gram equivalent weight. Once again, I will repeat gram equivalent weights. What is meaning of gram equivalent weight of a substance is number of parts of a substance that displace one part of hydrogen or 8 parts of oxygen or 35.5 parts by mass of chlorine. That we will call it as a gram equivalent weight. So, this normality has got a specific information about gram equivalent weights. In this, that gram equivalent weight is also said to be obtained from the molar mass. So, we can have a formula here in this, that is molar mass divided by n factor. I can write n factor. What is n? F stands for is n factor, that is different for different kinds of substances. The n factor may be acidity for the bases or basicity for the acids or some number of electrons transferred in a reaction. Okay, that is called as n factor. So, we will have clear detail about what is n factor for a particular substance also in the coming discussion. Okay, this is about a clear picture about what is normality. I hope you are understanding, right? So, normality is number of gram equivalent weights of a solute present in solute or substance present in 1 liter of solution. So, the formula, the symbol for the normality is capital N. So, the formula you can write it as weight of the solute by gram equivalent weight into 1000 by V in ml. So, we will move ahead in this concept by discussing the details of gram equivalent weights of some of the substances before doing the calculation. Okay. Now, we will see. So, the molar mass may be molecular mass also. So, here I am going to just give you some ideas about the n factor or number of displaceable hydrogens in a acid also. So, for acids I am taking some examples. Hydrochloric acid, I am taking hydrochloric acid. So, this hydrochloric acid number of displaceable hydrogens is 1 only, that is I can call it as n factor. So, in such case what will happens about the molecular weight of gram equivalent weight of this HCl. So, that means gram equivalent weight of HCl is molecular weight by 1, both are same only. It is 36.5. So, 36.5 by 1 is 36.5 only, that is gram equivalent weight of HCl. So, if you take another example like monobasic acid, that is HNO3, basicity is 1, this for this also. So, 1, in this case gram equivalent weight of this acid is again gram molecular weight by 1, it is 63 by 1 will come 63. So, for nitric acid you will be having 63 is the answer for this one. Taking an example of sulfuric acid, in sulfuric acid we have two such kind of acids, such kind of displaceable hydrogens are there. So, 2 is the n factor. So, GeWt for this one is molecular weight by 2, molecular weight of this one is 98 by 2 is you will get 49. So, what is 49 means? 49 is the gram equivalent weight of sulfuric acid. That means 49 grams of sulfuric acid displaces only 1 part of hydrogen by mass or 8 parts of oxygen by mass, that is the meaning of it one. Similar fashion, if you write phosphorus acid H3PO3, in this phosphorus acid H3PO3 you must remember what is its structure also. In this structure if you see the clarity about this one, there are 2 OH groups are present, as the basicity of this one is 2. So, that is n factor, that means from this OH groups only for this oxo acids the hydrogens H plus ions will be displaced. So, gram equivalent weight of this phosphorus acid, whatever phosphorus acid is there, that phosphorus acid we can calculate using the formula GeW by GeW is equals to GMW molecular weight by 2. Hydrogen here 3 hydrogens are there, 3 oxygens are there, this 48 plus 3 51, 51 plus 1 phosphorus is 32. Okay. So, phosphorus is 31. So, it is 82 we can write. So, we can write 82 by 2. So, I can finalize this one as 41 only. Okay. In the same fashion, if you go with the another type of acid, that is phosphoric acid H3PO4. So, in this you will be having there are 3 OH groups are there. So, this one is tribasic acid, 3 will come for this one. In such a case, gram equivalent weight of this phosphoric acid is molecular weight by 3 will come. Actually, this total 4 oxygen 64, 1 phosphorus is 31, 64 plus 31 is 95 plus 3 98. So, 98 by 3 will come. So, 98 by 3, whatever 98 by 3 is there, how much will come? That is 3 to 32.6 odd will come, 6 like this it will come. So, that is phosphoric acid. When it comes to organic carboxylic acid, acetic acid CH3COOH, it has only one displaceable one. So, 1 will come here. So, gram equivalent weight of this one is nothing but 2 oxygens 32 plus 4 hydrogens 36, 36 plus 2 carbons is 24. So 60 is the molecular weight of this one. So molecular weight by 1 is 60 by 1 is 60 only for this one. Okay. In the same way, you can also see the H2C2O4, that is oxalic acid. In this oxalic acid, you will be having two such things. Why? Because in this oxalic acid, you have the two OH groups are there like this. So H2C2O4. So 2 oxygens are there, 2 hydrogens can be displaced here. Basicity of this acid is 2. So the GEW for this one will become equals to molecular weight by 2. Molecular weight of this one is 90. Total is 90 will come. 90 by 2 is 45. For example, if they are giving dihydric, means here 2 waters also will come in the crystalline stage. So you will see 63 for that one when you consider 2 waters. So that you should see exactly from the formula only given in the problem. So depending on the formula only we will write, this is the formula, we will write 90 by 2, 45 will come for this oxalic acid. Okay. Now we are going to see some of the other different examples which telling about the acidity of bases, acidity of bases. So we will see bases. In such case, the N factor is called as acidity. Okay. Now for base what we will do? For base what we will use, number of hydroxyl groups present in a molecule of base is known as the acidity of the base. So we will take bases now. In bases what we will do is, we will take simple examples to understand the concept. That is, first we will consider sodium hydroxide. In this there are only one OH group is there displaceable. So N factor is 1, that is nothing but acidity of this base. So automatically GEW will become equals to molecular weight is 40 by 1 is 40 only. Not like that, if we have potassium hydroxide given in the problem, it is also N factor is 1 only. Potassium is 39.1, oxygen and hydrogen total 17 plus 39.1 is 56.1 will come. So 56.1 is the gram equivalent weight of potassium hydroxide. Likewise, we have barium hydroxide is there, BaOH twice is there. In this there are two OH groups can be displaceable. So the total barium hydroxide molar mass will be 171 will come, divided by its N factor is 2. So we will write it as 86.5, 85.5 will come. 18, 11 is there, 11 means 5.5 will come. Okay. Suppose if it is given a little differently, then depending on this total only we will write. So how this one, that is based on barium value also. Similarly, we have some other salts are there, like salts. If you take sodium carbonate, okay, the sodium carbonate base N factor is 2. Why? Because here charge of the cation or magnitude on the charges on the charged ion will be considered as N factor. So in such a case, sodium carbonate molecular mass by 2 will come 53 as the gram equivalent weight of the sodium carbonate. Not like that. If we have some other things like potassium permanganate given, KMnO4 given, an acidic medium they have given. Here what will happens in acidic medium, this permanganate manganese Mn2 plus will convert into Mn Mn plus 7 convert into Mn2 plus. So 5 electrons will be transferred in this one, and the oxidation reaction, in the redox reaction. So that 5 will be considered as the N factor for this one. So the molar mass of potassium permanganate divided by how much you have to write? We will write 5. Molar mass of potassium permanganate is 158 will come, divided by 5 if you write, you will get 31.6 is the answer for potassium permanganate. In the same way, if you see another kind of volumetric titrations, dichrometry, K2Cr2O7, here chromium is going to change from one stage to plus 6 to plus 3 in this one. So 3 electrons will be changed. Total of one chromium is 3 electrons, 2 chromiums are there, 6 electrons will be transferred, that is called as N factor. That case, molecular weight of the potassium dichromate, whatever is there, molecular weight of potassium dichromate divided by 6 we will write, it is 294 by 6 is 49 will come for the potassium dichromate. Why? Because here 6 electrons transfer is happening, that is N factor. In this case for acidic medium, I am telling only about acidic medium only here. So depending on the number of equations in the redox reaction chapter also, you can get a clarity about this one. Okay. So these are the different kinds of GW values, gram equivalent weight values of different substances. Okay. Let us see the next detail. Okay. Now we will see some problems on this one. Let us see a problem on the normality case. What is the normality of HNO3 solution? HNO3 solution containing 6.3 grams of 6.3 grams per liter of, they are given per liter of the solution. So very clearly given 6.3 grams is there in liter of the solution. Okay. First of all, what is GEW of HNO3, that we have to know. We have already listed out that one, that is 63 is the GEW of HNO3. Moving on to that, what is the weight of that solute nitric acid? Here is 63 grams given. So it is very clear, normality is equals to weight of the solute by gram equivalent weight into 1000 by V in ml. So or if you write later means you can write here 1. So you can 1 by 1 is 1 only. So you can write 6.3 by 63. So 1 by 10 will come. 1 by 10 means it is 0.1. So here in this simple calculation we got 0.1 is the normality of the given solution. That normality 0.1 whenever comes for any solution given, that we can also call it as decinormal solution. Do remember what is decinormal. Sometimes they won't give what is decinormal. The meaning of this normal solution is they are given the normality of the solution indirectly as 0.1. Okay. Let us move to the another model example we have. Okay. Next question is, next problem is calculate the weight of NaCl. Calculate the weight of NaCl present in 250 ml of 0.1 solution, 0.1 N solution. So, 0.1 N solution means normality given directly as 0.1. But what is normality? Formula we have weight by gram equivalent weight into 1000 by volume of the solution in ml. In this we have to find what is weight. So, weight is equals to normality into GEW into volume by 1000. So, list out some values given in the question. Normality already given is 0.1. GEW for NaCl, sodium is total is 58.5 will come molecular weight, that is itself is GEW also. Why? Because its N factor is 1. So, 58.5 is the gram equivalent weight of NaCl. Volume of the solution given in the question is 250 ml. 250 ml. So, if you substitute that all these things here in this, it is 0.1 into GEW is 58.5 into it is 250 divided by 1000. So, if you simplify all these things, you will get 1.465 grams of it. So, 1.465 grams of this sodium chloride is present in 250 ml of that 0.1 N solution. That is the meaning of it. Okay. Let us do one more problem for the normality. That is, calculate the normality of 5.3% weight by volume solution of Na2CO3. See, this is the question we have little differently given. 5.3% weight by volume means 5.3 grams of sodium carbonate is present in 100 ml of solution. So, here from this percentage meaning is weight is 5.3 grams and volume is 100 ml. Volume is 100 ml. That is the meaning of this one. And moreover, we know GEW for sodium carbonate is 53 and volume already we have. So, what is normality formula? Normality is equals to weight by GEW into 1000 by volume in ml. So, weight is 5.3 we have, GEW is 53 into 1000 by volume is 100. So, if you cancel, this is 10 times 53, 10 into 5.3 is 53, again 53 by 53, you will get answer 1. So, 1.0 normality. 1 is the normality of this solution. Okay. Hope you understand this model. Let us do one more, which is the final one in this discussion we have, right? See the next problem and the last problem in this session. The specific gravity of 84% weight by volume pure H2SO4 is 1.752. So they are given the specific gravity density. They are asking us to find the normality of the acid solution. Find the normality of acid solution. See, whenever this type of problem comes, we have one more shortcut, that is normality can be calculated by using this formula. Whenever this we are giving specific gravity density, specific gravity will be multiplied with percentage into 10 by gram equivalent weight. If you consider this formula, you will get everything. Okay, what is the formula? Normality is equals to specific gravity into percentage given weight by volume into 10 by gram equivalent weight. Just practice this formula, you will get the answer. Specific gravity answer is 1.752, percentage given is 84 into 10 by gram equivalent weight of this acid. What is this acid? This acid is sulfuric acid. Sulfuric acid gram equivalent weight is 98 by 2 is 49, we know. So that 49 if you substitute, you will get the answer. So simplification, how much comes? Let us finalize it and tell the answer. It is 1.752 into 84 into 10 divided by 49. So we have 30.03. So we have 30.03 is the normality of this solution. So normality of a solution, whenever they are given density or specific gravity, you can use this formula. In a case of molarity, if they are given, suppose the same thing, then you will use gram molecular weight only in the place of GEW to find the molarity of such solutions. Okay. So this is this end of this small session about the normality. We will see in the next session with some principles of dilution of solutions and their mathematical ideas. Okay. Until have a nice day. Thank you.